Hi everyone, welcome back to GetBlock podcast. Today's guest is Dmitry, CEO and founder of SQD, a company that building infrastructure for on-chain data. And I actually had a chance to meet Dmitry in person in Buenos Aires at Ethereum conference, and we had great conversation that left pretty ton of insights afterwards. And I thought it need to be podcast. There is no way I will keep it only for myself. So today we are going to dig into what actually happening in the blockchain data market right now, where we're going to get, and how SQD protocol actually work under the hood. So if you're a developer, investor, or you just interested in Web3 data, Web3 world, I think you find something interesting for you. So, Dmitry, welcome to podcast.
Yeah, hi Alex. Hi everyone. Thanks for having me and inviting me to the podcast. Once again, I'm Dmitry. I'm a CTO at Subscript Labs, and pleasure to speak here. And really eager to discuss the current landscape and the crypto market.
Yeah, thanks for joining us. So, and as usual, first question, tell us your story from the beginning, how and why Subscript did appear almost 5 years ago, and then how it evolved to SQD that we see now. Tell you about your major turning points that you went through as a team. So,
Yeah, that's a great question. And my interest in blockchain data actually started earlier. I was working at a project called JStream. They were designing and developing decentralized social media application, something like YouTube. And back then, there was a big interest in substrate-based chains, and essentially that was a separate substrate-based chain in the Polkadot ecosystem. And I joined the team specifically for developing some kind of an indexer so that they can quickly show metadata and quickly search across the videos. So you can imagine that this is actually quite critical for any application that wants to deliver actual video content. And back in the days, it was already difficult to get the data out of the blockchain nodes. So I was very quickly frustrated that in order to get anything, I would have to go to the node and get this data again and again. For example, if I want to change a schema or I want to change the shape of the API, I had to resync everything. And then the blockchain node, which contained all this information, essentially was a key bottleneck. So I decided to build some kind of a cache for this, very simple. And then it immediately sped up all the productivity. And this is what the prototype of the indexing pipelines that we've built afterwards. So that was essentially the key insight that I later submitted to hackathon, and that was obviously like very dirty prototype, but still the idea was there that in order to get the data, you don't really have to go against the blockchain nodes, which were originally designed to be a consensus machine, not a database. And instead, you would rather want to store this data somewhere else and reuse it over and over again. That back in the days was just an idea. So I also saw how, for example, the graph was already there, and there was obviously a lot of interest in the Ethereum space and virtually nothing in the substrate space because they were incompatible. And then essentially 6 months afterwards, I got a call from Marcel, who I knew from a previous project, and he said, like, yeah, where we're up to. There is like an interest in the Web3 space. Let's do something. And I told him about this idea, and I told him that there are actually quite a lot of teams building in the substrate. And then let's just try to start a company. And this is how we drafted the first white paper with a vision of building a truly decentralized network. So it's not just like some centralized server, but rather a Web3 service that is capable of serving this data for many teams. And very quickly we got our first users, and that was the key validation. So that's how we got the validation that there is a real demand in the market, and that in turn was the key kick for our seed round. And yeah, the rest is basically history. So it was like very clear that there is a huge gap between the amount of innovation, money, and interest in like building the blockchains themselves, right? So trying to make final blocks faster, trying to make throughput bigger, TPS, like all that, and it's still there, but very little was very little attention with respect to how you actually use this data and how you actually build applications on top of that. And this like data part is really like picks and shovels that is really overlooked. I think only the graph was trying to build something that kind of completes the stack, but it was obvious that it's not something that can scale and can go beyond just Ethereum blockchain.
Yeah, got it, got it. And who are your users today? So maybe you can share some stories or the use cases, because when we're talking about blockchain data, it's pretty wide space, or what can happen here. And who are your current users now?
Yeah, I think we're not somewhat special. Uh, our user base and the change in our user base really reflects the changes of the space overall. And I think we, like as a Picks and Showers company, really ride different ways of hypes, so to speak. So, for example, when I think it was 2 years ago, NFTs were a hot topic. We had quite a lot of projects building in an NFT space. So they were building marketplaces. Uh, for example, Decentraland were one of the OGs, and they're still using us. But of course, they're like trying something. I also like just like to stay relevant. Then there were like different meme coins and launchpads era where we had a lot of interest on that space. Then there were like a lot of Solana projects. Then, for example, Monad or like some other chain appears, and then we suddenly have a spike in projects building on Monad or like, for example, like building some cross-chain applications. So we really like across these 5 years have witnessed the shifts in the narratives, and like whenever narrative is it is interesting that people still really need this data to really need to build on top of that, and they basically like come to us, right? Because like we provide a cheap and fast and reliable access to this data. So when it comes to now, we do see a shift, and this shift is mostly towards bigger institutional clients. And when it comes to use cases, it's getting bigger and bigger on RWAs, stable coins, and also like in general, bigger customers who are not necessarily even Web3 natives. They, for example, want crypto rails integrated, or on the Web3 side, there are companies who are building for this Web2 giants. They also need some kind of rails. And also, pure Web3 companies like Morpho or GMAX, they're basically the giants who survived. And like in general, the crypto space is seeing this flight to quality. So there are many projects, they basically died out, but the ones who are still alive, they're getting bigger and stronger, and specifically in the DeFi space, right? So we have this consolidation, and we have institutionalization on their side, and at the same time, they really need higher quality. So that's why we're like having more and more enterprise-grade requests when it comes to SLAs, data verification, data validation. And here, I think we have a very compelling edge compared to like this traditional way of accessing the data, is that whenever you request the data from us, you always get the same response. If, for example, you're working with an RPC node, then there is no guarantee for that. Even if you have some kind of redundancy, you always can have like different RPC node clients, different implementations, so the node itself simply can be overloaded, and then you get a response with, for example, like partial transactions from all logs. And this is something like of a live runtime compared to serving something from essentially like a static file, which is like validated, audited, and then you're guaranteed essentially like to get the right response, no matter how high is the load. So yeah, we definitely like see the transformation, and we transform ourselves according to the market.
But what about today's AI narrative? Because a lot of company building AI agents, they also need consume data, and seems like that should be different workflow than enterprise do that, because it's another technical implementations, it's another user experience. Do you see in this direction, and how you adjust your system in order to fit current needs of AI agents ecosystem?
Yeah, definitely. I think right now we're still in a sort of a transition period where AI usage has increased tremendously, but it's still mostly humans who use AI tools in order to do maybe faster what they used to do before. So I think we're still not in the like full autonomous AI era, where the agents like manage the subscriptions, pay for the data, and operate completely independently. But we are already in an era where instead of building something on your own, you would rather ask Claude Code, and then the Claude would probably suggest you. So that, first of all, changes the way that we think about our documentation and the website layout. So it has to be easily readable for AI and AI agents. And I think it's becoming really a standard that you have separate kind of files. Also the skills. So if before the AI, you would need like a real human in order to build an indexer pipeline, and you would need this human to be proficient in whatever language and understand the documentation. Right now, it's all about fitting the right context and the right skills. So we have like over 100 skills specifically for building AI indexers, and that really pays off. So for example, if you want to build a dashboard for say AI liquidations, you would rather spend like a couple of days before, but now really just like 5 minutes, and it's actually one shot, and it's almost immediate because the data access is also very quick. So this is like what happens right now, being AI friendly when it comes to AI tooling. The next step, of course, is to enable X402 so that the AI agents can pay and access this data on their own. This is something that we are constantly thinking about, and at the same time seeing how others do this, right? Because our model expects that there is a recurring subscription, and for AI agents, something like micro subscription on or pay-per request would be more efficient. At the same time, we also see, for example, Cloudflare enabling AI subscriptions for AI agents. So different scenarios. I do believe that we're still in a phase where it's not the market. It's not the main kind of customer, but this is something that may easily be there like in a few months, because the speed of changes is just mind-blowing. Something that was basically science fiction a few years ago, right now it's just like some mundane that we're like so used to it.
Yeah. I think that we will back to this question about agents in our next question block. Now I want to ask you about technology that is working under the hood of SQD. Give some high-level architectural overview of your system, because when we had conversation in Buenos Aires, I was very impressed by the decentralized data lake, where you store huge amount of data and how you smartly manage it, process it. And maybe you could give some high-level overview for those who not deeply dive deep into this topic and not familiar with these ETL pipelines, how it looks like, and what advantages it gives to from data processing standpoint.
Yeah, so first of all, I think I would start by highlighting why we we've built a slightly different data lake, essentially, compared to something that you would just take off the shelf, for example, like Spark or any enterprise grade data lake houses. So, first of all, the blockchain data itself is quite interesting because it's essentially append only, and it's not something that you would update all the time. So if you're interested in the historical and real time data, it's normally something that is already sealed in the block. So if you get all the block information, you would never really need to update it. But at the same time, it's a huge amount of data, right? So we have right now more than 20 active blockchains. Overall, I think there are like hundreds, and like we support more than 200. And it's just like a sheer amount of volume, sheer amount of data. And the second thing is that as a user, as a consumer for this data, you're normally interested in a relatively small subset of this data. But this data is spread across millions of blocks. So for example, you want to pull a history of your wallet transactions, or you want to have a full analytic data about, say, AVI liquidations or like prediction market trades. This is still a small amount of information compared to the whole history across all the blockchains. So that means that you would need to have an efficient way to extract this data and query it. So that kind of design allows us to make it more efficient and bespoke, as long as we utilize these trade-offs and make it more performant. And in practical terms, that means that we can ingest this data once and write it into a very efficient file format called Parquet files, which has two properties. First of all, it's very easy and efficient to query it natively, so it's essentially like a file as a database. And second, it has good compression properties. So that means that something that requires, say, 10 terabytes on your disk if you run a node would become just like 100 gigabytes if you put in the Parquet files. And the third property, of course, something that I already mentioned, is that since it's just a file, there is no chance that you have a corrupted data once you start querying it. And moreover, you can verify that this data within this file is correct, simply because the blockchain data, it's another important property, is self-certifying. So essentially, you can verify and calculate Merkle trees, log Bloom filters, and verify that the data that you've received from the node is actually correct. So even if the node itself, like the upstream, glitches, then you can easily identify that the answer is correct. This is something that would be very hard to do if you do it in real time, but it is very easy if you do it sort of like a background process. So you're optimistically get this data, but once you verified it, you're 100% sure that this data is always correct. And then you need like an infrastructure to actually like put this data on, and this is where subscript networks comes in. So we have like thousands of nodes who are incentivized with the SQD network token. At the same time, this SQD network token is used in order to access this data. So each node keeps like a local copy of some of the files. So it's like sharding across thousands of nodes. And then we have a device called router who basically identifies which nodes to connect to in order to respond to the user request. Then we have additionally like some services to allow real-time data so that we have very low latency when it comes to like very fresh data, which is not yet propagated to the network. So yeah, it's actually like a pretty multi-tier and complex architecture, but for the end user, it's just like a single endpoint with an API to query both historical and real-time data.
Is it correct to think about it as we have this decentralized data lake actually with workers, that several thousand of these workers, and if I remember it properly, it's around several petabytes of total volume in your network.
Right.
You pass all this blockchain data, listen it via RPC, right? Pass it to the most convenient for querying format and put it in the with redundancy on these different workers, and customer can send a call, query, and retrieve any data from any blockchain from particular for particular range of blocks for particular blockchain, right? And your customers can do it easily with just one query instead of do a lot of calls to get this data.
Yeah, exactly. That's good explanation. So all the blockchain history and only blockchain data across 200 plus chains that we support is packed into this Parquet files. So each Parquet files covers roughly a few hundred blocks, I think, if I'm not mistaken. And then there's like this thousands of Parquet files are distributed across the thousands nodes in our network with very high redundancy. And then once you make a query, for example, give me transactions from my wallet from block 1 million to 2 million, then our router understands that, okay, here is just like a small subset of nodes who have this data, so who have this Parquet files, they can query it. They under the hood send multiple requests simultaneously, so then there is redundancy. There is like coverage across like different block ranges, and then whenever it comes first is aggregated, and then you end up with a stream of continuous data, and it all happens very quickly and very smoothly due to like bunch of optimizations. But yeah, TLDR is that it's essentially like a data lake on flat Parquet files with high redundancy and a pipeline which transforms data stored in blockchain into these Parquet files continuously, so that are continuously updated and added and distributed.
What is Parquet file? You mentioned that it's several blocks inside each Parquet files, right?
Mm-hmm. Yeah. So for each block, there's like all the information that you have. Yeah.
So, for example, if we take Ethereum blockchain, let's take block number 1 till block number 10 will be put into particular Parquet file, and we will have several copies of this Parquet file over your decentralized network, right? And
Yes.
even if one worker goes down, and this Parquet file still can be extracted from the network because as alive. And how you guarantee statistically that it will be possible to extract file from the network? What is system of monitoring here?
So it's not just a node going down; it's actually about even the latency. So whenever a query decides that, okay, we need, for example, some data from this range of blocks for 1 to 10, it the router simultaneously sends multiple requests to different nodes who contain this data and pick up the fastest. And then the router also has an active statistics table, which basically says that, okay, these are the nodes that respond fast, and these are the nodes that respond slower. And the incentives for the network is done in such a way that if your node is not doesn't for some reason respond, so for example, your node served relatively few queries during the months, maybe because it was just too slow to respond, maybe because it was down, for whatever reason, then the amount of rewards that you get from the network will be much less. So essentially, it's a self-regulating market, which ensures that if your node kind of underperforms on average, then you just like get fewer rewards, and that incentivize running better hardware, answering faster, and so on. And this is the economic guarantees that you have this availability. But also, it's just like statistically that as long as you have efficiently decentralized network and your replication factor is, I think it's something like 15 to 20 right now, then the probability that no nodes, so basically all of them go down, it is virtually zero. But of course, there could be like catastrophic events, but
Yeah.
essentially, this is impossible.
Even in this case, because of distribution over globe, it will be very low probability that this particular parquet will be gone. So,
Yeah. Yeah, but
okay,
even then, we kind of like have a backup copy, so the network will basically assign the Parquet files to other survival networks. So the network always reshuffles. So it's not that, for example, your node gets the Parquet files and it stays there forever. It's designed in such a way that it's like constantly like slightly reshuffling this Parquet files. And that also guarantees that on average, even you are unlucky and the data that you have is not that much in demand right now, due to this reshuffling, on average, you will at some point get this like hot hyped data, so to speak, that like hot, and then your node will be like serving a lot more requests. So that's why on average, the number of requests served is like a good benchmark on how your node in general operates. But at the same time, it is the client essentially who decides which network, which nodes to pick and which nodes to query, right? And obviously the clients will always take the best performing ones.
interesting. Can you please tell a little bit more about economic model? Because as I know, you pay in SQD token to serve nodes properly, but at the same time, I heard that there is USDT part that workers get paid in USDT, and it's more solid for infrastructure companies. So can you describe these parts?
Yeah, I think there's like a little bit of confusion here. It's not that the workers are paid in the USDT, even though technically that there is such a possibility in the future. But what is live already is what is called revenue pools. So the economic models that we have is that it is not SQD is not a payment token, right? So I think the first generation of decentralized network had this like very simplistic model that you basically pay and you pay in your native token for to access the resource, similar to how you pay in Ethereum to pay for gas. But in reality, this is very bad user experience, because if you just like want to get some data, you're required to purchase some tokens, and this thing is very volatile, right? So it can be like $10 tomorrow, $1 today, and you never even know. Like, and you have to keep these tokens on your balance sheet and whatever. So paying in stable coins is basically a non-negotiable quality. So, but at the same time, so what we are doing is that we are using SQD token as a resource limiting factor, essentially. So in order to access the data, the portal has to have SQD staked. And basically like one SQD locked in the portal represents a 1 unit of bandwidth, basically like how much of the total network resources this portal can consume. So there is a minimal requirement of 1 million SQD locked in the portal right now, and like once they're locked, then you get access to like that particular bandwidth. So it's deliberately a relatively high amount of tokens. And even though like some customers may decide to have such a like long-term investment and like for normal traffic that would be something like 10 million SQD, then yeah, it's possible to make such an investment if you were like really thinking strategically. But most of the time, you would rather pay a monthly subscription fee in fiat. And here we got like I think a like pretty elegant solution where there are token holders who like hold SQD long term, but they are not really data consumers, right? They're like mostly like retail guys, right? But then they can essentially provide the SQD to lock in the portal, and at the same time receive some of the revenues generated by this portal from the stablecoin subscription. So this is what we call revenue pools. And then it becomes like a win-win situation. The data consumer gets a flat fee for a monthly subscription to get the data, and the SQD holders get essentially a revenue share for providing SQD to this portal and making sure that it works. And then it gives a very kind of like clear value proposition for holding this SQD because it suddenly becomes a productive asset. And moreover, this design also includes burning some SQD from the proceeds, so that the part of this like revenue generated by this portals is used to buying automatically like buying some of the supply and then burning it. So then gradually it offsets the rewards that are paid in SQD to the workers.
Got it, got it. Very elegant solution because economics in the pin project is pretty complex and seems like you managed to handle this because all the pin project have this pain how to reward participant of the network in a proper way in order to make their token usable by participant of the network. Cool.
Right, it's always like a chicken and egg problem, right? And also like making it really usable, and also like ensuring that you have enterprise grade SLAs so that you can actually rely on this, right?
Yeah, yeah. So let's move to block with a bigger picture of blockchain data market because, for example, currently there are several players. SQD, Graph, Goldsky, Allium, Duner, PC provides they're all about data, but it's about different data. So what boundaries, how you see boundaries between them and where is this market heading over the next several years? How this data landscape will looks like in several years?
Yeah, it's a great question. I think that we have somewhat of a specialization similar to what we see in mature market, and at the same time consolidation. So, for example, Alchemy like bought multiple companies. For example, Satsuma, I think, for hosting some graphs. Also, I think they bought some of the RPC providers. So there is obviously like this attempt to consolidate the market. At the same time, for example, Dune is focusing more on analytics data, even though they have, I think, right now real-time API, but still mentally, I think people mostly think about Dune as dashboards. And then there is like this lower layer data access, which are RPCs. And then there is kind of analytic structured data layer, which is DeFi Llama, Dune again, say RWA XYZ, which is really not just blockchain data, but also like a lot of off-chain data blended in, right? So for example, if you want to have RWA analytics, which is clear for financial professionals, then you also need to study the actual documents, which are not even stored on chain. You have to figure out like what are, for example, are the credit terms, what are the securities that are backed. So it becomes more and more kind of vague. And that draws like a relatively diverse picture. I think Allium, like Gold Sky, like Allium, I think gravitates towards like more of a like ready-made data. Gold Sky also focuses, I guess, on like having kind of like simpler like building blocks. We are best at like providing efficient access to this lowest layer on the raw data. And this is something that is good for teams that are building their in-house or like bespoke solution. So for example, in many ways, big enterprises, they want to own their whole stack, and they also don't like vendor lock-ins. And this is where I think it's great if you can provide like a self-hosted solution, or like at least provide some way for redundancy, because everyone of course is saying that like our services are the best. It never goes down, but the reality is different, right? And as a customer, as a client, you really want to diversify it. At the same time, you don't really want to pay a lot for this diversification, and you also want to own it, right? Because there are multiple stories where people were relying, for example, a wallet API, and then suddenly the company is acquired, and then the API is down, and then like you basically are barefooted, and you like immediately want to find a way to replace it. But if this is something that is up in the stack, and this is something, for example, like an API that is like very bespoke, then you end up in a situation where there is like no one-to-one replacement. You have to build something, or you have to adjust, and this is like a huge pain, right? In that case, RPC API with all their like drawbacks is actually a standard, and they're like good and bad for the standard. The bad is that it's like very difficult to improve it and change it, because that was like really something that goes back to even like Bitcoin nodes, right? This like RPC API standard was developed without any vision of how things will become in the future. And then it was even impossible to predict there will be like hundreds of chains and like this huge backfield of million blocks. But it was ossified very early on, and like there is like very little change since 2014, I think, of this like early Ethereum clients. But then it became a standard, similar to how HTTP becomes a standard. And then the good part is that like multiple independent players basically support this. So we can switch from Alchemy to GetBlock, for example, right, easily. And it's like very good for the consumer, I think, because it like gives him dependence on the vendor. So yeah, I think there will be like more and more flights to quality and kind of commodization of this layer. And then there will be like two kind of branches. One is like this impulse to try to own the infrastructure, and the other thing is maybe like buy some data from established vendors. Something, I guess, similar to what happens in TradFi, but like longer, maybe like 10, 20 years ago.
As I understand, when we're talking about owning your data, owning your pipelines, you're also providing your SDK, right? That allows team not to develop from the scratches, but use already mature tooling in order to build the ETL pipelines. So as I understand, big companies will consider you as a source of data, of on-chain data. And via portal, they will extract this data and use your ETL pipelines in order to process this data and put it to their local databases according to their needs, right?
Yeah, we want to we try to keep this optionality, because the portal exposes an HTTP endpoint that you can consume with anything with UCRL, but also we do provide like a very extensive tooling and SDK that comes with AI skills. So as I said, you can just prompt and then like get a working pipeline within minutes with different connectors and adapters to BigQuery, to Postgres, to ClickHouse, like multiple examples. So this is something like of an ecosystem which is all open source. People just use it, but at the same time, some companies would prefer just using the raw URL and like raw API because, for example, they have like a specific language stack or they have like specific requirements. But overall, I would say that like mid-tier is a very kind of efficient. We also provide a platform called SQD Cloud where you can immediately deploy your indexer so that you don't really even care about the infrastructure to run it. So you have like end-to-end pipeline from raw data to structured API like GraphQL or like simply like put it into the database and everything is turnkey. But this is again an optionality, so you can run it on your own prem, you can like run it in our cloud, you can develop it using our SDK, or you can run on your own. So, for example, one of our active community members even like developed their own like Go SDK in order to have ultra fast and low latency solution for poly market data with like bunch of optimizations. Yeah, so this is like a very opinionated at the same time, lots of options depending on the use case.
I want to clarify this part. You mentioned also that your system not ready just for historical data, but also for real-time high-frequency data, right? So, for
Right.
example, high-frequency activities like Hyperliquid or now Solana, BNB chain with sub-second slots also will be processed properly. This data will get to customer in a fast manner, right?
Yeah, I think the reason there is this misconception is that for a while we had our old product, which we call V2 archives, and due to the way that this data is packaged, there was some delay of like maybe like few hour latency for this data, and the rest. Should be processed through the RPC endpoint directly. So this is all right now is being deprecated. As of now, we like introduce limits, API keys, and eventually like all this V2 archive endpoints will be sunset in favor of the portal. And the portal provides like a single API with real-time data and historical real. So the way that we do it is that the portal itself has a real-time component and the historical component, which is directly connected to the network. So they're seamlessly stitched together whenever there is a query that, for example, requires both historical and the real time, or for example, if it's just real time, it hits there's like hot cache of the real time. But at the same time, the properties are the same. So you get validated response. You have always the full response and so on.
Got it. Got it. Okay, and the last question about the future. So blockchain becoming real part of big technological systems. How you see landscape and role of blockchains in real world use cases, and especially from data perspective.
Yeah, that's a great question. I think we're witnessing what's happening already today. So you don't really need to be a prophet in order to say what's going on. Before, I think even 2 years ago, it was mostly blockchains themselves were designed to be more of a B2C. So, for example, you have a DeFi app and you expect your users will come directly to your application and interact directly with the blockchain, right? Open a wallet, sign a transaction, deposit some money, all essentially for like a few hundred or maybe like a few dozen gigs, right? Who are just like reshuffling their capital for rewards. What's happening right now, it's blockchain becomes rather a B2B technology. So big players like Stripe, Visa, MasterCard, they are all acquiring companies that you would never even hear about, but they're building this infrastructure and payment rails directly under the hood. And they're reselling it as a single Stripe endpoint, but at the same time, they are using, for example, stablecoin rails in order to get better fees and remittance processing times, right? So this is what is happening. It's not even a forecast. And when it comes to the data, that again just becomes more enterprise grade. So I think products like DeFi Llama, something like community build, will evolve into something that is sold in the same way as TradFi data is sold nowadays. Maybe some institutional grade analysis. When it comes to it's like lower parts of the stack and like raw data access, again, the biggest consumers will be on the institutional side and enterprises. And for the end user, it will be just the same interface, right? So, for example, an end user right now doesn't know that you're using Kafka on Oracle and the hood, right? But at the same time, you have a huge, I don't know, AWS subscription bill. And this is just like how it works. Yeah, so it becomes more institutional. It becomes more enterprise grade when it comes to reliability and SLA. And at the same time, it becomes a lot more mature and more pragmatic, right? So, for example, this Tempo blockchain, they don't really want to become as decentralized as Ethereum, but at the same time, they have very clear product vision when it comes to settlement times, when it comes to APIs. And for example, they introduced this abstracted wallet feature, which specifically is designed to allow crypto payments for like small and big enterprises without like introducing more infra for that. And at the same time, Stripe, which I think is the biggest investor in Tempo, right, is just wrapping into products that everyone is using already today. So probably there will be no difference even at all at the surface. It's just that the underlying financial structure, which is essentially parallel to what we are used to, is being built. It's almost ready, if not ready. It's just like more efficient because it's almost instant and it's universal and it's like cross-border. It's just, yeah. And everything that we used to in TradFi, stocks, bonds, securities, money, like bank accounts, everything moving there as well, simply because this infrastructure is easier to work with. But at the same time, you also will probably like put this like bunch of regulations like layers, which also can be country dependent. For example, this like Clarity Act in the USA. So there are all like different layers on top of this, but the infra is there, and people just like go where they can have a more efficient solution, both in terms of like technology and the costs. So yeah, this will be just like buried.
Yeah, it seems like that. It seems that all current activities like trading on centralized exchanges will move on on-chain rails, more on-chain
Mm-hmm.
activity, more requests from companies to get data and process this data in a particular way. Dmitry, this was great. Thanks for your time, for being so generous, for your vision, insights, and you paint pretty clear picture of where this all headed. So I really hope SQD becomes one of the teams that will define that future. And we believe that we are in partnership with your company, and I believe that we GetBlock and SQD will build this unchained future in the most reliable way as possible. So, thanks for your join. To everyone listening, go check out SQD. Links are in the description. Share with someone. Send us comments. We will great to get your vision about data markets. Dmitry, I think that we will do our podcast again somewhere in future as you develop new features So thanks for joining us.
Thanks a lot for having me. It was a pleasure. And yeah, really happy to work together with GetBlock. Thanks a lot. Looking forward to the future podcast episodes.
Great. Thanks.